Okay, so the last video we did something clever. We took the slow work of the live request and we dropped it onto a queue. So the user did not have to wait. And right at the very end, I said one thing that I want to come back to now. A queue buys you time, not capacity. So let me actually show you what happens when the time runs out. Let's say your workers can finish 100 jobs a second. That is your real limit. 100. Now 150 jobs a second start showing up. So every second 100 get finished and 150 arrive, which means every second 50 more jobs pile onto that queue than come of it. And that gap does not close on its own. The line just keeps growing with no end. And here is the cruel part. The longer the line gets, the longer every new job has to wait behind it. So everything gets slower and slower until you finally run out of memory or threads or connections and the whole service just falls over dead. So if that arrival rate stays above what you can handle for long enough, the queue itself becomes the thing that kills you. And the natural instinct here, the one that everybody has, is to just push through it, accept everything, queue it all up, work as hard as you can possibly can. But that is exactly what kills you. And think about why for a second. Take the kind of work someone is actually waiting on, a live request or something time sensitive. By the time a job like that has sat in the queue for 30 seconds, it is often already useless. The person waiting has given up and left. The moment has passed. So, you would be burning your last scarce bit of CPU, finishing work that literally nobody wants anymore. You are cooking meals for customers who already walked out. So, trying harder does not save you here. It just makes everything worse, faster. So, what is the right move when you genuinely cannot keep up? And honestly, I think this one is genuinely hard to accept at first, right? It is going to sound completely backwards. The move is you start saying no early and on purpose because here is the reframe, and it is really the whole video. Rejecting some of the request is not your system being less available, it is the exact opposite. It is how it survives. Think about it. If you accept only the work you can actually finish and you cleanly turn the rest away, then your core keeps working for everyone you did let in. But if you try to say yes to everything, you slow to a crawl and you eventually serve no one. So a fast, clean no is not a failure. It is a protection. The failure here is deliberate, and that is the whole point. And there are really just two moments where a system has to reach for this. No. One, when too much work is coming in and you are simply full. And two, when a service you depend on has gone sick and it is starting to drag you down with it. Two different problems, two different tools. So let's take them one at a time. Okay, movement 1. Too much work is coming in, you are full. Now, at high level, the classic tool here is called backpressure. And let me be really precise about what the word means because people muddle it. Backpressure is specifically this: the overloaded service reaches back up the pipe to whoever is sending it work and says, "Hey, slow down, I am full." That's it. It is like a cashier looking up at a huge line and calling out, "Please, no more people for a minute." The pressure flows back the way it came, from the drowning end upward towards the source. And back pressure has a few cousins, other ways to handle being full, and you should not lump them all together as back pressure, right? They are all their own things. 1. A bounded queue. Remember the queue of hours that give forever? Just give it a limit. So the moment it is full, it says full and turns new work away before your memory runs out and the server dies too. 2. Load shedding, which is honestly quite clever. When you are forced to drop stuff, drop the cheap stuff first. Keep the payments flowing. Quietly drop the customers also about recommendations. You sacrifice the unimportant to protect the important. And 3. You can just reject cleanly and fast with a honest signal. There is even a specific code for it. Remember status codes? A 503. Service unavailable. The server just saying, I am over capacity right now. Please come back in a bit. And quick note, that is different from the 429 from the rate limiting video. That one was aimed at one greedy user. This 503 is the whole service honestly putting a hand up and saying it is full. Okay, movement 2. And this one is sneakier and honestly a lot more dangerous, right? Here, it is not that too much is coming in. It is that one thing you depend on has gone sick. So let's say at high level, your checkout service calls an inventory service just to check the stock. Normal day totally fine. But now, inventory gets slow, really slow, slow enough to be useless, even though it is not technically down. So, what does checkout do? It calls inventory and it waits And the next checkout request comes in and it also calls inventory and also just sits there waiting. And pretty quickly, every worker thread inside the checkout is frozen. All of them stuck, waiting on sick inventory. So, checkout can now serve nothing, not even the request that had nothing to do with the inventory. And then it spreads. Checkout's own callers start timing out and retrying. And hey, this is that retry storm from the retrace video, remember? Except now it is aimed at a service that is already sick. So every retry just makes it worse. And the sickness ripples outward, one service dragging the next one down, one sick service taking the whole chain of healthy ones down with it. And that has a name, a cascading failure. So, how do you stop that domino? Now, staring at a frozen checkout, the instinct is to just keep trying, keep calling inventory, keep retrying, push through it, right? But by now, you know the trap. Trying harder only makes it worse. So, the fix is the opposite. Checkout needs to stop calling inventory, at least for a bit. And the tool for exactly that is borrowed straight from your own house, a circuit breaker. You know how. If something shorts in the wiring, a breaker trips and cuts the power to just that one circuit. So a fault in one room cannot burn the whole house down. Same exact idea for a service call. And one important thing to get right, this breaker lives inside the caller, inside the checkout, and it only watches that one dependency. So when it trips, it does not mean inventory is down for the whole world. It just means I, checkout, have had enough trouble calling inventory, so I'm going to stop for a little while. It is a local call, my problem, my decision. And it runs on three simple states, just three plain words, right? Normally it is closed, which just means working. Calls flow to the inventory like usual, and the breaker sits quietly and watches. But if enough of those calls start going bad, it flips to open, tripped. And now it stops calling inventory altogether. The calls that actually need inventory just fail fast. They come back instantly with a clean, sorry, you cannot check stock right now, instead of freezing a thread for 8 whole seconds on something you already know will fail. And notice the knock on, because those threads are not frozen anymore. Checkout's other paths, the ones that never touched inventory, keep working. And for a less important dependency, instead of an error, you might just show a fallback, like quietly hiding the customer's also bought box. So it does two things at once as well. Your users are not left hanging, and because you finally stopped hammering it, the sick service gets some room to actually recover. Two quick clarifications on that word bad because they both matter. One, a call counts as bad if it failed or if it just was too slow. A reply crawling in at 8 seconds when you needed it in 1 is an useless as an error, right? And two, it does not trip on a single unlucky call. It waits for a rate, like most of the recent ones going wrong. Okay, so once the breaker is open, how does it ever come back? After a short cooldown period, it slips into half open testing. It just lets a couple of requests trickle through and to quietly check is inventory back yet. If they succeed, flip back to closed, all better. If they fail, slide back to open and wait a bit longer. So that is the whole mission. Working, tripped, testing. So let's tie it all together. When your system is in real trouble, the wrong instinct is to try harder. The right move is to say no early because controlled failure beats uncontrolled collapse. And honestly, it comes down to three words: full, sick, fast. When you are full, too much work pouring in, you push back, slow the sender, cap the queue, shed the cheap stuff. When a dependency goes sick, dragging you down, you cut it off with a circuit breaker and give it room to heal. And in both cases, you fail fast. A quick, clean no. Never a slow, silent yes to work you can never finish. And that quietly wraps up a whole run of these videos. Rate limiting, retries, queues, and now this. All of them really about the same thing. How a system stays standing when the whole world throws more at it than it can handle. But every single one of those tricks has a hidden requirement, right? To shed load, you have to know you are overloaded. To tip a breaker, you have to see that inventory is failing. So the natural next question is, how does a system actually see itself? How do you watch one request move through all these pieces and spot where it got stuck? That finally being able to look inside your own system is where we go next. But for today, when it all becomes too much, do not try harder. Say no early, clean, and fast. See you in the next one.